Hello everyone, I want to use the Khan Academy video as a jumping off point for this video. Notice I have the exact same function that he had, which is f of x equals x squared plus 1. And I'm doing exactly what he did. I let my n typically is the number of rectangles, so n equals 4 rectangles, that's what he did. I let a, which is where you start, be 1. And I let B be 3. So you're starting at 1, ending at 3. All right, that's all that means. So then your delta x, which basically is the thickness of each one of your rectangles that you're going to squeeze in here if you have 4 rectangles, is found by asking yourself how far you went from 1 to 3 or from A to B. So in this case, our delta x equals 3 minus 1. And then it asks you, if you're going to go from 1 to 3, how many different rectangles are you going to squeeze in there? And that's why you're dividing by 4. Right? So this is how he got 2 over 4 or 0.5. Okay? So then what the Khan Academy guy was saying is that you start at 1 and you just go up in 0.5s. So 1, you get a 1.5, and that'll get you to 2, and that'll get you to 2.5, and then finally you get to 3. So notice we have 1, 2, 3, 4 rectangles that we can squeeze in this region. All right, now the Khan Academy guy, Sal, he did the left sum, which was by going to his left endpoints, tracing it up, and that determined each of the heights. What I'm going to do now to make sure that you guys have a balanced view is the right sum. They are calculated separately. All right, so here's my first rectangle between 1 and 1.5. And I have to choose the number that's on the right. So notice 1.5 is clearly on the right of 1. So we go there. And that's going to determine my height. I'm not going to pick my finger up because the height has to be parallel to my finger. So there you go. Right? And then I move over. I got to choose between 1.5 and 2. Notice 2 is on the right. There's that box. Between 2 and 2.5, 2.5 is on the right. And then between 2.5 and 3, the 3 is on the right. Okay, so there are the 4 boxes that I need. Notice I get too much box, right? I'm trying to find the exact area under the curve, but I get these pieces that are excessive, if you will. All right, so then the Khan Academy guy was saying that you should be able to find the area of these boxes, because if you can find the area of these 4 boxes, then it'll approximate the exact area under the curve between 1 and 3. All right, so what is our approximate area? Well, it's found by doing base times height, or height times base, right? Because the area of a rectangle is equal to base times the height. Now I'm going to do height times base. Now there's a reason. The Khan Academy did the exact same thing. All right, so let's think about how the height was calculated. All right, so in this case, the height was calculated right here. Notice that is your y value at 1.5. So this is f of 1.5. So you take f of 1.5 and you multiply it by the base. Notice you know what your base is. It's 0.5, right? From 1 to 1.5 is 0.5. And you're going to add to that. You move over. You do your height. Notice your height is determined right here at x equals 2. So if you were to go over here, notice this would be f of 2. Right? Your y value at 2. So this is f of 2 times your base, which is 0.5. Right? That's how far it is from 1.5 to 2. Okay, you would continue on. Right? This would be f of 2.5. So we're going to add to this plus f of 2.5 times 0.5. Okay, so I know I'm running out of space. But let me keep going. And I'll add to that this last rectangle, which this last one's going to be f of 3. So this will be f of 3 times 0.5. Okay, you'll notice then all of my work that I never use the 1, right? Because the 1 is on the left. Okay, so I found the height here, 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 and here. All of those dots mark the heights of the rectangles that I have. I never found out what happened at 1. All right, now the reason that I and the Khan Academy guy are writing it in this way is we see a pattern, right? So you'll notice it's f of x times delta x. F of x times delta x. F of x times delta x, and f of x times delta x. So what are you doing? Each time you're finding your height at a specific x value and then multiplying it by your base, and then you move on and you add on to that height times base, and you add height times base, you add height times base. So I want to transition into this notation. You are adding the heights times the base. Fancy way of writing that, f of x times delta x. Okay, now the fancy way to say add is sigma. Sigma means add. Okay. Now there's a reason that I'm writing it in this way. I'll get back to that in a minute. But before I do that, before I get to that, I want to do this calculation. Okay, so f of 1.5, if you remember what the Khan Academy guy is saying, is that's just a matter of plugging 1.5 into your original function. So then your approximate area is, let's see, you're going to take 1.5, you'll square that, you'll add 1, and you multiply that by 0.5, right? So let me put them right next to each other so you can see, right? So ignore that. F of 1.5, there it is, 1.5 squared plus 1. Multiply that by 0.5, and then you move on. Plus 2 squared plus 1 times 0.5 plus 2.5 squared plus 1 times 0.5 plus 3 squared plus 1 times 0.5. All right, let me zoom in so that you can see what I've done. Okay, evaluate your function at your specific x value, and then you're multiplying it by the base of 0.5. Right, height times the base. This is height 1 times base 1 plus height 2 times base 2 plus height 3 times base 3 plus height 4 times base 4, right? So everything's accounted for. Okay, let me remind you, you're adding the heights times the base, and here's the fancy notation. Okay, so we're a little bit closer, because now if we can write it like this, then certainly we can understand that this might be able to be more easily understandable if we had an infinite number of rectangles instead of a finite number of rectangles. All right, I'll explain more in the next video.